Thank you for coming. I'm going to present to you Matroid, the computer vision company, and in doing so, we'll essentially go through an entire setup of running TensorFlow on Amazon AWS with Kubernetes for the purpose of computer vision. So first of all, this is joint work with myself and a large team of people at Matroid, so it really doesn't do it justice to only have my name on this slide, but there's only so much room on the slide. The basic idea behind Matroid is that we ingest many streams. And well, this is the quick overview of the talk. So I'm going to quickly introduce Kubernetes and TensorFlow, quickly introduce Matroid, and then go through a live demo of Matroid. And so we're going to get to this point here. We're going to get to this point where we show you a video player. Now, this video player has in it detector that we will create. This particular detector has been created to look for Brad Pitt, as you see here, and Angelina Jolie. And we made this detector with the web platform, and then we had it run on the video. And then the places where the two of them show up, or one or the other shows up on this video player here. And what I want to do is walk you through the architecture details for how do you get there from essentially scratch. So a quick introduction to Kubernetes. The basic unit in a Kubernetes cluster is a pod. A pod is one or more containers. A container, I hope most of you know, is very much feels, tastes, and smells like a virtual machine, but is lighter weight. So it actually hooks into some areas of the kernel to not have to replicate everything that a virtual machine would have to replicate. So, but you can think of it as a virtual machine for the purposes of building applications. And so the basic building block in Kubernetes is a pod. There are many containers in a pod, and the containers in a pod share one IP address. So it's as though, even though there are multiple VMs, they all have the same IP address. And the key feature that Kubernetes provides is that pods are scalable and fault tolerant. So if a pod goes down, Kubernetes takes the responsibility of bringing it back up. If you would like a pod to be replicated many times, you can tell Kubernetes, look, I want this pod to be replicated 5 times, and all of its containers will be replicated 5 times and available to you. So this is essentially the simplified overview of Kubernetes. What it looks like is there's the master node. There are many minions. Each minion has inside it several pods, and each pod has inside it many containers. And in this case, we use Docker containers, although they do support other kinds of containers. So this is the much more interesting and in-depth overview of Kubernetes. So if you actually wanted to understand, well, why is it that this thing is fault tolerant, we would have to go through this much more in-depth diagram. And here is actually, shows you that, look, the pods share an IP address, and you can see that through the proxy, and there's some distributed storage to allow for fault tolerance. So these slides will be available online, so you can go and look at this. And then this is actually sourced from the Kubernetes GitHub. So there's more details. I'll share these slides after. So stepping back for a second, now I would like to show you the pods that we built for Matroid to get to that computer vision player that we spoke about at the very beginning. So there are pods for each one of these logos, right? Each one of these logos has a very different functionality. So Nginx is essentially the first thing that people talk to when they go to Matroid. This is actually a reverse proxy. You go to matroid.com, and what will happen is you'll be presented with Nginx. Nginx will then route your request to one of our Node.js web servers. So the Node.js is a pod in its own. Nginx is a pod in its own. And what happens is then the web server is presented to you, and you can log in and start doing some stuff. One of the things that you can do is register a stream with Matroid, a video stream. So a video stream for the purpose of monitoring that video stream. So I'll be showing you how to create detectors. Once you've created a detector, you can then have the detector monitor a video stream 24/7. That stream would be ingested via Apache Kafka, and there's a whole pod dedicated to Apache Kafka. So then, and that pod will ingest streams securely. So there's a whole other pod to serve SSL certificates, because we really want to make sure we never sort of come short of serving SSL certificates. And then there's our database. So our, every website has a database for user information and all other kinds of information. That's MongoDB, has its own pod. We have a pod for Amazon Web Services. Why do we have a pod for Amazon Web Services? Well, for those of you who are comfortable with Amazon, they rent machines to you. Amazon Web Services rents machines, and all of the things I'm telling you run on machines that run on Amazon. So Kubernetes asks for machines from Amazon, from AWS in particular. Now, Amazon has this thing called a spot marketplace, where they let you rent machines for a lot cheaper if you're willing to take on this risk that the machine might go down at any time. They give you a 1-minute warning that the machine is about to go down, and then they're going to take the machine down. But then in return for that, you get a much cheaper machine. And so this is a marketplace to let them essentially give away some of their excess capacity for a cheaper price. And it's very good for startups, because startups want to be cash savvy, right? So how we deal with this is that we actually have, and there are two types of instances. There are the reserved instances, which will never get evicted, and then there are the spot instances, which are cheaper but will get evicted. So what we have is we have a pod dedicated to running Amazon in a reserved instance that then watches all of the other pods that can be potentially evicted. So, for example, some of our web servers are redundant, but we have them in case we need them for load. If they get evicted, this reserved pod will then bring them back up for the sake of making sure that the site can handle a load. And then, of course, there's a pod for TensorFlow. So I'm going to go into each of these pods much more in depth in a little bit. The TensorFlow pod runs a convolutional neural network. This is, I'm going to go over maybe a 3-minute overview of what a convolutional neural network is, because it's absolutely necessary for going back to that video player that I showed you. How is it that we can detect the face of Brad Pitt? How is it that we can detect the face of Angelina Jolie? The power there is from a CNN, a convolutional neural network. So this is how a convolutional neural network works. There is a 2-dimensional patch filled with numbers that we don't know about. Just double checking. Can everyone see my my mouse pointer? Because it's really helpful for this diagram to be able to use the mouse pointer. Great. So you see this patch here. This patch is filled with numbers that we don't know. And what happens is every single little number in this patch gets multiplied by the adjacent number in the image. And then all those numbers get added up and fed into another layer. And then a similar process happens in the next layer. And a similar process happens in the next layer, all the way to the very last layer, where there are just 4 numbers. And these 4 numbers will essentially be a combination of all these other previous numbers that we don't know how to set. And then these 4 numbers, whichever one is higher, will say that the label of the image corresponds to the number that is higher. So there are 4 numbers. If the highest number is the first one, we would say this is a dog. And well, then the question you should be asking is how on earth do I set all of these numbers in the middle? The way to set these numbers is by looking at lots and lots of data. So we look at hundreds of millions of images, and then set a function and try to optimize a function that sets these numbers in a way that makes the numbers basically predict the training data as well as possible. So these numbers are set by machine learning, of course, and the basic idea is that even though this process was really, really complicated, we had all these layers and all these multiplications, we can actually still figure out the derivative of the gradient of our function of how well these numbers fit our training data, which is essentially our loss function. We can figure out the gradient of that by using an algorithm called backpropagation, and then use that gradient to consistently make our guesses for these numbers better and better until they're at a point where they work out. And that's essentially the machine learning process in 30 seconds. But the basic idea is that we know how to do this now. And every single machine learning framework pretty much does this. Every single deep learning framework does this. All of them do it. The one that we use is from Google Brain. It's a happy coincidence, actually, that Matroid is a generalization of a tensor in some ways. So what happens is Matroid was incorporated in October 2015, and TensorFlow was released in November 2015, which is an interesting coincidence. And actually now there's the Vector Institute from near the University of Toronto. We are, of course, a company. We use TensorFlow, but that's the only connection there. So TensorFlow does a lot of computation, an absolute ton of computation. And what's happening there then is we would like to be using a GPU machine to do the computation. TensorFlow uses a ton of compute that is not done particularly well by traditional CPUs and needs a more powerful workhorse. And so you would like to be able to tell Kubernetes, hey, Kubernetes, when you're scheduling my TensorFlow pod, I would like for you to put it on a machine that has a GPU. And so TensorFlow will do that. Sorry, Kubernetes will do that. It will schedule our TensorFlow pod on a machine that has a GPU. We say, look, this particular pod has a resource requirement of a GPU. Please schedule it on such a machine. And it will ask AWS for GPU machines, P2 instances and G2 instances in particular, to schedule the TensorFlow pod. And then the Amazon machine, like I said, is essentially dedicated to having us have a lower Amazon AWS bill by asking for the cheaper machines. So after all of that, you've seen our pods, you've seen some of our architecture. And what I'd like to do is essentially show you how it all comes together through a live demo. And so just to back up for a second, I never actually told you the basic idea of what is the product. So Matroid is a studio for creating and using detectors. And these detectors, much like a metal detector finds things on the beach, you'll be able to find things in media and streams, video streams, using a Matroid detector. So what I want to show you now is actually exactly that. So I'm going to switch out of slides now and go on to a demo. Great. Okay, so when you log on to Matroid, you'll be presented with a screen like this. You can either use a detector, or you can make your own. So if you try and use a detector from somewhere online, if you try and use a detector from somewhere from someone else who's already made one, you can. And this is an example of one. This detector can detect airplane, bicycles, birds, boats, and so on. So let's try and dump an image into this. I'm just going to go on to Google News and pick out some random image. Let's say this image off of the BBC. Oh, it's not an image. Is this an image? Looks like it should be. Let's get the URL of that image. And then go back and dump it in here and see what this detector thinks about it. So the detector has detected a person there, a person there, and a person there, and that's all it's detected, because out of the list of things that it can detect, only those people showed up. So it can detect some other things like cat, chair, cow, dining table, and so on, but those weren't in the picture. So it figured out at least that there's people there, which is exactly right. So what we'd like to do is get there. We would like to make a detector without having to just use one off the shelf, right? And so, by the way, when we went to Matroid.com, we saw Nginx routed us to one of the pods that had a Node.js app running, and so this is Node.js that you're seeing. So let's make a detector for those people that we wanted to. Like Angelina Jolie was one, right? Angelina Jolie. I want to make a detector for her and Brad Pitt. So we're going to create a detector for these two. Let's hit create. Actually, will someone give me the name of their favorite celebrity, any celebrity you like, just so that it's a little bit more live and interactive with the audience? If anyone's sort of got a little bit more of a rare celebrity would be nice. Jodie Foster, let's do that. All right. So Jodie Foster, we'll add her in as one of the people, submit, and so she'll be added in as an additional label to this detector. So here are so far what's happening is what we're showing you is examples of what we think are Angelina Jolie. And this is essentially coming from our own mini search engine. We have examples from the Common Crawl, from other databases of images that have been tagged. And so you can look through and select examples of what you think are Angelina Jolie. These seem like reasonable examples of Angelina Jolie. And if you want to be particularly stringent, you could go in and select an area. You could say, oh, I think you should be able to select an area, but my mouse is being weird. There we go. Good. So you can go in and select her face if she's showing up next to a lot of other people, right? And Brad Pitt as well. These seem like reasonable examples of Brad Pitt, although this one seems to have multiple people in it, so let's deselect that. And then Jodie Foster, yeah, this seems like Jodie Foster. So she's showing up in all of these examples. So let's go. We only need like a few examples of a single person. So I'm going to deselect these remaining examples. There's no need to have so many. And the more we have, the more time training takes. So I don't want to spend too much time on that. And so these seem like perfectly good examples of Jodie. Now, what if we didn't have examples of the person? Well, of course, we can upload our own examples from the computer. We also have our own video player that lets you select select snippets of video. So let's say I have this video here that is, this is a video of Steve Jobs unveiling the iPhone. And this video player lets us select frames from that video. So I can go in and say, hey, this frame is relevant, this frame is relevant, this frame is relevant, and this frame is relevant, and upload them. And then they will be there available to use. So I could be like, well, this is actually also an example of Jodie Foster. And of course it's not. So I'm going to go in and deselect these examples because they are not the right kinds of things for us to be giving in as Jodie Foster examples. And if you recall, we could also, I could also record from a webcam, but my webcam is being used for this conference, so I'm not going to screw up the conferencing software for that. We can also use recordings from a stream. So this is actually a live stream from somewhere in Louisville. It's a public camera somewhere in Louisville right now, happening right now. And we could record from this camera and then use the camera examples as examples to the detector, so the detector doesn't get confused with weird things. So this is a recording from the stream, and what I mean when I mean weird things is that what if the stream had some kind of glare, or if there was some object in the stream that was constantly being confused for something that wasn't the right thing, and we would like to normalize that out by providing examples of it to the detector. And this is actually the Matroid office live right now, and there's no one there because it's the weekend. And we could also do the same thing. So we have all of these detector examples, and we're going to make this a face recognition detector, and then hit create, and then that should create a detector within a few minutes. So right now it is 11:01 here, and so it's 1 minute past the hour here, and this should finish pretty quickly. So I'm going to name this AI with the best detector. 14% done. It should be done in a few seconds. In the meantime, let's go and get a video of Jodie Foster. So Jodie Foster YouTube, and hopefully we find a reasonable video of her. And so this is I hope this is not a weird video. I'm going to take take this video and use it when this is done. So by the way, the stream that I showed you earlier, the stream that was coming into the stream from the webcam in Louisville, that was coming in through Kafka. So the Kafka node was using was basically fetching from the webcam and then showing it to us in fairly live fashion. It was probably a delay of a few seconds from what the webcam was seeing and what we were seeing. So this will be done any second now, and we'll be able to dump in the video that we just picked out from Jodie Foster. This is all happening now on the GPU machine. So this training is being done via TensorFlow on the GPU machines. And so the face detector is now ready to use. We can use it for whatever we want. So let's search a video with it. So the video that we're gonna search is the one that we just picked out of There's no need for the sound, right? So that's good. There's a bunch of people in this video, and hopefully we'll be able to classify the video and find Jodie Foster. So let's set the sensitivity to Jodie Foster to around 40% on the video, and there she is. So and she was there a little bit earlier too, and so she's not being tracked. She's not here, right? And then she comes back, and if you can see, the video player has been tagged with where Jodie Foster shows up. And she looks like some kind of interview with some random people on a video show and on a sort of sick talk show type thing. There's some other people that are famous and who I recognize. Yeah, see, she's gone. She comes back. So you get the idea here. So now we're convinced that this Jodie Foster detector is working fairly well, right? So then what could I do with this Jodie Foster detector? Well, I can do all kinds of things. One thing I could do is I could monitor a stream for her 24/7. So I'm gonna take this Jodie Foster detector and run it on, say, Bloomberg. So what's happening now is we're connecting live to the Bloomberg stream. And this is again happening through Kafka. Kafka is sucking in Bloomberg and then routing it to a TensorFlow box to have a detection happen. And then we're saying, well, look, is Bloomberg currently showing any Jodie Foster? And surprisingly, no. Usually there's some people, but look, there's no face in this is Bloomberg Live, and there's no face happening on Bloomberg right now. There's some news about Puerto Rico sadness happening. So yeah, that's not quite doing, when you do live demos, sometimes this sort of thing happens. What would have happened is if there was a person there, we would have tagged their face and we would have said, this is not Jodie. Sadly, that's not the case here. So let's stop that. What I want to show you is what the other things you can do with a detector. So you can then monitor a stream 24/7. This is part of something we provide as a service. So I have here a detector that just runs in perpetuity, monitoring Bloomberg for the president and some other people. So Trevor, this detector, I made it exactly as I made. This is a politics and comedy detector. It detects Trevor Noah, James Comey, and Donald Trump. And I made this detector exactly as you saw me make the other detector. Nothing fancy. And so what I had it look for is Donald Trump. So if we go look at this, these are occurrences of Trump showing up on Bloomberg in the past few hours, actually. So let's see if he's showed up today yet. We haven't detected him showing up today yet. The last time we detected him was 10 p.m. Yesterday. Even though he's making that funny face there, that's him, right? Similarly, we have a detector running for the matrix object detector that I showed you very early on. We have that running on our office, and so you can sort of see our office times that we come in. Like someone usually comes in at 9 a.m. and then we're there till around 8 p.m. And actually, this chunk of time that you see is empty is when we went go-karting. So at 8 a.m., this is when we came back from go-karting. And this is right before we went go-karting. So that's actually, I think that's me, or that's Ryan, one of our engineers. So this is the person detector. It's not detecting who it is, it's just detecting that there is a person. And so this is part of the service that we provide using all of this setup. So let's go back to the detector we just made, the Jodie Foster detector. contact video with Jodie Foster. Is that a request that you want this detector run on that video? Well, how about this? I'm going to share this detector with all of you at the end of the talk, and then you can run that video through it yourself, and you should be able to see the results, okay? So I don't wanna, yeah. So I'll share the detector. You see this button here, the share detector button? Once I hit it, you will actually be able to use the detector as well. So I'll send that to the chat list afterwards. But before I do that, I want to show you a little bit more about what we've done here. So of course we can try the webcam. So you saw try streams, you saw monitor streams. What I want to show you is a little bit more of the advanced stuff. So of course everything I showed you is available via an API. You can call a detector via an API. You can create a detector via an API. You can do everything I showed you via an API. You can also inspect the contents of the model in a much more interesting way through our work essentially with open source. So we have this little button there, called Matroid board, that will start showing us the more interesting innards of the model. So we can look at things like what is the accuracy of this model. This is built off of Tensor board from TensorFlow. We call it Matroid board because we've tweaked it in various ways, and then we're Matroid, so we call it Matroid board. But this is TensorFlow, Tensor board from TensorFlow. And these are some of the false positives that the detector makes mistakes on. And so this is Jodie Foster, but the detector didn't figure out that it was Jodie Foster. And I guess it's not really surprising. It doesn't even look like Jodie Foster to me, probably because of the bubble gum, and it's like a really old photo. This is also Jodie Foster from when she was a kid, but we never had any examples of when she was a kid. So we also got it mistaken there. We mistook this Angelina Jolie photo, and this Brad Pitt photo. And these are sort of, you look at these mistakes, you can figure out, well, why am I making these mistakes, and provide more examples along those lines. We can look at the neural network that is underlying the detector. Again, this is only useful for a deep learning engineer. So if you're a regular machine learning engineer, this might not be the best thing in the world for you. You can look at the distributions of the weights. You can look at the histograms of the weights of the neural network, and you can look at a pretty cool embedding of the training data. This is a three-dimensional embedding of the training data for these folks that we've, as the model is seeing them, as the detector is seeing them. So the red is Brad Pitt, the yellow is Angelina, and the blue is Jodie. And so you see that they're fairly well separated from each other, except for these few examples. Like this example of Jodie Foster is pretty close to this example of Angelina Jolie. So if we provide more examples that look like this, we should probably be able to make training better. So this is the kind of thing that you can learn by looking at the examples here. So we have a way essentially to inspect the model and then make it better. How do we make it better? By providing feedback. So back to the detector here. I'm going to drop a random image onto the detector here. So I'm going to take a photo of myself and just like put it into the detector. And of course, I'm neither Jodie Foster. I'm neither Jodie Foster, nor Brad Pitt, nor Angelina Jolie, right? So my face got detected, but I'm neither Brad Pitt, nor Angelina Jolie, nor Jodie Foster. So I want to give feedback to this detector. This detector is saying, well, is this Brad Pitt? I say, no, this is not Brad Pitt, and the correct label is none of the above. And so now this is available as feedback. And when we hit redo detector now, what will happen is we will land back in studio mode, but the example that I gave is now available as a negative example to the detector. So if it so happened that we had made a mistake on my face, we would have been able to give feedback here, and then that feedback would have gone in and made the detector better, and the mistake would not have happened. And we can redo the detector pretty quickly because you saw how fast that was, right? It took like 2 minutes to make the detector. So hopefully it's within the patience of the user to redo the detector with the change. So I'm going to delete this detector, and I'll actually share that detector with you at the end of the talk and send it out. But let me finish on my slides, and then we'll go back. Okay. So back to the slides here. So we saw the live demo, and what I want to show you is sort of go over what we just saw. So we saw a studio for creating and using detectors. We had the library, we had the click and drag interface. It was pretty easy to use, I think. We have an ever-growing detector library. So now that we have that Jodie Foster detector, I can share it with you guys, and everyone will be able to use it as well. So there's a constant growing library of things that can be detected. We have our own video player with computer vision at its core. So if we want to be the computer vision company, we better have a computer vision player. We have a type feedback loop that lets you iterate on detector quality. So you saw that detector, and then we redid it to help you make it a higher quality detector. There's an API to help you integrate any of these detectors in your apps, and there's stream monitoring as a service. And we have work sharing amongst users with privacy. So when you create a detector, the detector is yours. You are not sharing your data with anyone unless you share it. So at the end of this, I'll show you how to share this, and I'll share it with you guys, right? Like I said. And then at that point, I will have given up the fact that I want my data to be private. So the data that I use is private until I share. And we very clearly tell you that, look, you're going to make your data more public if you're going to make your data public if you share. You know, we used a lot of open source, and so we definitely want to give back to open source. So this is something where we're putting our words where our mouth is, or our money where our mouth is, by putting our time and effort into writing a book for TensorFlow. So I'm writing this with one of my students at Stanford. I'm an adjunct professor at Stanford in machine learning, and a lot of my students are excited by the idea of being able to have TensorFlow and deep learning in the browser without having to go around all over the place. We've raised $13.5 million from Intel and NEA. We help Intel push the boundaries of their hardware. We're looking for awesome people to join us, and this is a quick plug. Essentially, if you're interested in this kind of thing, please look at matroid.com/careers and see if there's anything of interest to you. So yeah, thank you for your attention. Everything I showed you is available on Matroid. And let me quickly go and share that detector with you right now, and I will answer the other question too in a second. So this detector here, this is my detectors. It's in that list. This is the AI with best detector. I'm going to hit the share detector button and hit share. And then from now I can take this. Actually, I can even just directly send you this video that we saw. I can share it with you. So I can share results, copy to clipboard, and now I will just paste that in here. And that's available to everybody, so that everyone can play around with this detector. All right. Okay, questions time. So what's my contact for follow-up on the Matroid platform? My email is reza@matroid.com. That's pretty easy, right? So please reach out to that, and you'll be able to use it. Is Matroid a generic thing on top of TensorFlow, or highly specialized towards image video data? We are highly specialized towards video data. I'm not sure what you mean by, is it a generic thing on top of TensorFlow? We don't provide TensorFlow as a service. We provide only computer vision tools. And we make computer vision easy to use by non-developers. That's our goal. We currently don't do like speech recognition. We're not a machine learning as a service company. We're not a deep learning as a service company. We provide computer vision, and we think there's so many problems in computer vision that we don't want to get distracted from that. So it's our focus. Focus is computer vision. How is the performance of the system? Well, quality-wise, I mean, you saw the quality for faces, you saw the quality for objects. The performance in terms of how fast it is, you also saw that. It's real time. It's essentially 10 times faster than watching the video, which means that we can monitor streams in real time. So if Donald Trump shows up on Bloomberg right now, I would get a notification. And I think, yeah, so, you know, if that's a reasonable answer to the performance of the system, since there's only two things I can think of there: quality and how fast it is. How much manual training would be required to build an office detector? Very little. So by an office detector, if you mean the faces of people in the office, it would require maybe 10 examples of each of the faces of the people in the office. Yeah. The tricks to get it working fast is one of the tricks is obviously having a large a pool of machines, but one of the other tricks is being able to have a lot of transfer learning happening. So what we have is around 10 different pre-trained networks, as well as some really small networks of our own, and they all get used to try and create a detector. The next question is there a limit to the number of concurrent streams being monitored? There isn't really, because we charge per stream that we monitor, and as we charge more, we can afford to ask more machines from Amazon. And so what the real limit is how many machines can Amazon provide us, which I don't think we're going to hit anytime soon. How big is your pool of GPUs, if you can share? The pool of GPUs is actually constantly increasing and decreasing per our user demand. I can't share you exact numbers, but the pool grows as more people stream, as more people monitor streams, and then shrinks as more people stop monitoring streams. So Kubernetes actually does scale down as well as up for us. Would a trained model detector be able to be used offline, for example, on a mobile device? So when we train a detector, it's on our roadmap actually in this year to be able to export detector to some cameras. For example, a part of our deal with Intel is that we run the detector on their camera. So currently, as I showed you, there isn't a feature for that, but there will be. This is on our roadmap and very high on our roadmap. Can you post-process the video in real time? I mean, post-processing and the word real time are sort of hard to reconcile together, but I think what you mean is, can you go through a video and change it while the video is playing? I think that's what you mean, right? So censoring a face, we currently only put bounding boxes around faces, but actually people have been asking us for this censorship thing quite a bit. So it'd be pretty easy for us to censor a face. You know, we already put bounding boxes around the face, so it's sort of trivial to just blank it out. It's not a feature that's in here right now, but if that's a feature that will have you use the platform, we'd love to add it in. So please email me and we'll put that on our higher up on our roadmap. All right, everybody, thanks so much for your time. I appreciate you watching this on a Saturday, and thanks again. Have a good day. Bye-bye.